In the 1950s, planes started falling out of the sky. They were brand new to Havilland Comets. The engines didn't fail, the pilots didn't mess up. These planes failed because of the shape. The designers used rectangular windows. They didn't realize that a 90-degree corner is a lens that focuses stress until it rips aluminum apart. Think of stress like water flowing through a smooth, tranquil river. If you put a rock in the middle of the river or a sharp notch in a steel beam, the lines have to bunch up to get around it. That bunching up is stress concentration. This is K sub T. It's a multiplier. Your average stress is 10,000 psi, but you have a sharp corner with a stress factor of 3. Your actual stress at that tip is 30,000 psi. You just tripled the load without adding a single pound of weight. Let's prove it in the virtual lab. Both of these bars are the same material. Both bars get the same 1,000 pound load. Look at the corner. The sharp notch acts like a crack starter. The stress here is theoretically infinite at a perfectly sharp point. In reality, it yields immediately. Now look at the radius. By simply rounding that corner, we allow the flow lines to spread out. The peak stress drops by 60%. In forensic engineering, I don't look for the strongest part of the machine. I look for the corners, keyways, snap ring grooves, drilled holes. We see this in litigation all the time. A part fails. Someone blames the user for overloading it. But when we analyze the part, we find a sharp corner hidden in the design that multiplied the load by a factor of 4. It wasn't abuse, it was bad geometry. Engineering is the art of managing flow. If you are designing parts, spend the extra $10 to machine a radius. If you're investigating a failure, start at the corners. Subscribe for more breakdown of how things break. I'm Clay Brittain. Stay frosty. C4 is out.